So good morning, everybody present in the class. Probably this is good afternoon, more than nearly 12. Uh, so yesterday I have shared a drive video. Will anybody have gone through that? This T6 is nothing but anybody have gone through that? The video which I have shared in the drive yesterday. Okay, now tell me whether the slides are clear and whatever I speak is audible to you. Okay, then fine. So my question is, whether you have gone through that lecture because today, yesterday people are not present in the class. Only I think Sanjay Kar came at the last moment. Tutorial sheet 6, and the file was stored in his window. I mean in his drive actually, and I have shared that link. Whether you are able to go through that, whether anybody have gone through that. Hello, people in the class, please answer my query. Whether you have gone through that particular lecture, which I have given you an introduction about time domain specifications. Time domain specifications like rise time, delay time, peak time, maximum peak overshoot, and settling time for a second order underdamped system. Anybody have gone through that? I want responses, please, because I should know because I have planned it in such a way that yesterday I have to cover that, and today based on that formulas you will have some uh, okay, so problems will be discussed. So that's the idea. So yesterday what I have done is I waited for you. Okay, so only one came at the end, I think. But it is a recorded version. It is been stored in the drive of Sanjay sir. And he has given me the link. Even I have that link actually, but I have to download. Then you have to give me the permission. Okay, rather than a viewer, I have to be an editor or something. Okay, so that change I have requested him. If that is possible, I will also upload that in my YouTube channel. My question is whether anybody have gone through that lecture because I have shared that drive video yesterday in the group. I, either answers are invited. Either I doesn't want. I doesn't force you that yes has to be there. Okay, it might also be there as no. I will take this as no because yes, because nobody is saying ready to say yes actually. So obviously it is going to be no. So what I can insist now is you can go through that lecture. You see the drive link, download or I mean you cannot download it probably. You can view that. So you try to view that after this class and try to correlate it. Okay, that's the idea. Even I have solved one problem in that lecture also using the formulas which I have derived it, right? So let us start the tutorial session. This is again a tutorial sheet number 6, which is probably I have already posted it in your Google Classrooms with the key. Okay, both the key as well as tutorial sheet is available, and we will be discussing on the problems available in the tutorial sheet, right? And whether anybody have gone through that prayer, again I think the answer will be as usual, no, right? So let me start the lecture. So this is my first question under tutorial sheet number 6. Determine the unit step response of the control system shown in the figure, which is having a block diagram representation as in provided here. So from it, what is asked actually, I am supposed to find what is C of t. Okay, C of t. Anybody understood the question or Can anybody say what is the methodology we have to follow exactly? You can just unmute and say what is unit step response. If it is unit step response, what is R of S? What is the value of R of S? Hello? Kindly unmute and answer the question. Even it is going to be wrong, I am going to correct you. That's it. But without answering it, okay, it makes that you are not interested in listening. So please answer the question. R of S is equal to what is that you provided for a step response? How do you represent a step response in frequency domain? We have gone through that in the previous two lectures. Time response analysis of first order, test signals, time response analysis of second order. Okay, all these two lectures have given you brief idea about how you represent your step response, impulse response, ramp response, and parabolic response. Okay, so my question is, what is R of S is equal to? Okay, so maybe I can help you in that. R of S is equal to 1 by S, and this is your G of S, and feedback H of S is equal to S by 10 plus 1. So all these things are provided. So it is possible to get your C of S by R of S. From this, you can cross multiply this R of S, and you will get an expression C of S. If required, you can go for partial fractions and form it in such a way that it is possible to go for inverse Laplace to get your C of t. So that's that. All the derivations which you have seen in your first lecture, second lecture, particularly in unit 1 and 2, focuses on this methodology only. How a C of t can be obtained from transfer function C of S by R of S. Based on your input, R of S is going to be different. How to derive it, and what also, not also that actually, it also derives, it also provides an idea about how the relationship between the different inputs. Okay, getting out response based on the relationship between these inputs. Okay, that's it. So let us say we will take this problem and we will solve that. Let us say that after this also you will be able to get some idea. So as I mentioned, it is provided as G of S is equal to 10 divided by S into S plus 3. I hope that everybody has the writing material with you so that you are following simultaneously. You are also making a note of whatever we are discussing. So 10 by S into S plus 3 is your G of S, and H of S is S by 10 plus 1. And I am supposed to know what is my C of S by R of S. This is a negative feedback system. Okay, we have a negative feedback. So we say it like the closed loop transfer function will be G of S divided by 1 plus G of S into H of S. So what I will get? I will get it like 10 by S into S plus 3 divided by 1 plus 10 into S into S plus 3 into S by 10 plus 1. So what I will get? C of S by R of S is equal to, okay, 10 divided by, okay, numerator divided by denominator. So S squared plus 3S plus, again we will have a numerator of the G of S into feedback transfer function is S by 10 plus 1. So you will have it like 10 divided by S squared plus 3S plus 10S plus 10. This will give me 10 divided by S squared plus 3S, 13S plus 10. Is that correct? Is that correct? Yes or no? If you say it is correct, it is wrong actually. People are there or machines are there, I don't know. What is there actually? People are there or only machines are there? If I am posting a question, some response has to come out as yes or no at least. you will get 4s. So 10 divided by 4s plus 10. So this is your overall closed loop transfer function. So I want to know what is C of t. So what for that I will go by my method. C of s by R of s is equal to 10 divided by s squared plus 4s plus 10, and I can write it like C of s is equal to R of s into 10 divided by s into s squared plus 4s plus 10, which will become it like 10 divided by s into s squared plus 4s plus 10. Since it is unit step, I can write R of s is equal to 1. I mean R of s is equal to 1 by s. So if I include that R of s is equal to 1 by s, I will get it like, okay, this is again a small mistake I have committed. Let me correct it. Yes, now it is correct. R of s 10 divided by s square plus 4s plus 10, 10 by s into s square plus 4s plus 10. Now again, the problem is you are not having any, you cannot go for an individual root. Probably it's a complex conjugate root for s square plus 4s plus 10. And this particular format of the transfer function cannot be applied, okay, for an inverse Laplace to get C of t. So what I have to do, I have no other option, I have to go for partial fractions, and I have noticed that this particular term will have a root of what, a complex conjugate. Okay, so what is the method for going for partial fractions? Okay, partial fractions is 10 divided by s into s squared plus 4s plus 10 is equal to a by s plus bs plus c divided by s squared plus 4s plus 10. Okay, so which can be written as 10 is equal to a into s squared plus 4s plus 10 plus s into bs plus c. Up to this point, anybody have a doubt? Please, at least for that you respond. Up to this point, okay, up to the point where I have stopped now, please tell me whether I have any, you have any issues or doubts regarding what we are doing. No doubt. One person, right? Two. What about the others? Hopefully, four are there already. No, 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 no. Fine. Can anybody say what is A, what is B, and what is C? I can wait here for at least 1 or 2 minutes. You know how to solve partial fractions. We have already done it. Sanjay, no sir, in the sense you cannot work on it or you have no doubt, because your no comes very late after my second question has gone. Okay, let me help out. Let me help this actually. Okay, right. So 10 is equal to, okay, right. So even I can do any methodology. I can use any methodology. 10 is equal to, I combine this, multiply this 4a s plus 8n plus bs squared plus cs. I can group based on the coefficients a plus b s squared 4a plus c into s plus 8n is equal to 10. Now my equation is this one. So I can equate LHS and RHS. I will get a few equations. What are they? I will get a few equations. What are they? Constant A10 is equal to 10. A plus B is equal to 0. And 4A plus C is equal to 0. So I take all these three equations to the next slide probably, and I will try to solve that. So what are the equations? A into 10 is equal to 10. A plus B is equal to 0. 4A plus C is equal to 0. So the first equation provides me A is equal to 1 and B is equal to minus 1 is available from the second equation. And what is C? C is equal to minus 4. Is that right? Yes or no? These three equations provide me these results A, B, C. Is that right or not? Please tell me. Okay, fine. Yes, right. So now I can substitute these residues in my partial fractions where I get C of S is equal to A by S plus Bs plus C divided by S squared plus 4S plus 10. So this C of S is equal to 1 by S plus minus minus S minus 4 divided by S squared plus 4S plus 10. Or I can write it like 1 by S minus I can take it out. This is S plus 4 divided by S squared plus 4S plus 10. Again, these are all complex conjugate roots, so I have to do some manipulation. I have to do some manipulation in such a way that I get some format where I can take my inverse Laplace. So what I will do, I will do some manipulations. What I have done in the second order derivation of underdamped system, I will make it like S plus 2 divided by I think I have to add. I will make it like S plus 2 the whole squared plus root 6 the whole square. Okay, what is that? How it came actually? This I will try to explain it using a box. What is this? S squared plus 4s plus 4 plus root 6. Okay, root 6 is going to be 6, which means s squared plus 4s plus 10. So what I have done, I have converted this s squared plus 4s plus 10 of a format where I can take my inverse Laplace. So what I have done, I have done this denominator a small change. The type of the denominator has a different format, but I have not changed the value of that equation. The equation is same, but it looks like a different equation, right? So now I will be able to uh, segregate that s plus 2 the whole square plus root 2 6 the whole square plus I think this minus comes to the whole. Okay, so this also minus comes here also minus 2 divided by s plus 2 the whole square uh, plus square root of 6 the whole square. So what I will do, I will introduce uh, I will introduce the square root of 6 here, numerator and the denominator, 1 by square root of 6. Because the format, what I am looking here is L inverse of Laplace inverse of uh, S by S squared plus omega squared is equal to cos omega t. Laplace inverse of omega by S squared plus omega squared is equal to sin omega t. Laplace inverse of S plus A divided by S plus A the whole squared plus omega squared can be written as e power minus at into cos omega t, and the Laplace inverse of uh, is that omega divided by S plus A the whole squared plus omega squared e power minus at into sin omega t. So these relations are in my mind, and based on this relation, okay, I am trying to form this equation of such category. You can see that this s plus a by s plus a the whole square plus omega squared is now, you can see that here this format is looking like this. And what is absent here? This omega squared, this omega is absent. So I have introduced this root 6 and root 6 here. Okay, so this is looking like here. Omega by s plus a the whole squared plus omega squared. Got the idea? Anybody? Any doubts here up to this point? Please respond in the chat window at least. If you are able to respond using unmuting your mic, that is well and good. At least you respond in your chat window. Okay. So you are able to get that point. So இந்த ஃபார்மேட்டுக்கு நான் மாத்துறதுக்காக தான் அந்த ஈக்குவேஷனை I have changed that. Okay, so that I have, okay, so that is it. So I will go back to that. I will try to write it clearly here. 1 by s minus this s plus 2 divided by s plus 2 the whole squared plus square root of 6 the whole squared minus, okay, here you have a 2 square root of 6 and you have another square root of 6 s plus 2 the whole square plus square root of 6 the whole square. I have written the same in a clear way. Now if I take Laplace inverse, taking inverse Laplace, I can straight away write it like C of t is equal to 1 by s, it becomes 1 e power minus 18 2t into cos root 6t minus 2 by square root of 6 e power minus 2t into sine square root of 6. You can stop at this point, or you can go for your own expression. You can go for your own expression probably. Assigning a right angle triangle, then this root 6 2 and all can be done, but that is not required. You can have it as it is. So this is your final output response. This is your final output response for this problem. C of t is equal to 1 minus e power minus 2t cos root 6t minus 2 by root 6 e power minus 2t sine root 6t. Any doubts here? Hello? Hello? Keeping the class, I have. Please come out with the answer. If you have doubts, please ask me. I am ready to explain it again. If you have a doubt in Laplace inverse, probably you have to brush the basics of the Laplace, because you have studied Laplace in your probably in your third semester or second semester, I hope so, in your mathematics. So you go there and refresh yourself with these formulas. We have also seen the same type of usage of Laplace transformations from the differential equations in your first unit. Okay, this substituting the values of from the table of Laplace. Okay, that you have to refresh again. Okay, if you have doubts, please you can inquire now. So the first problem, the question is they are asking for the time response analysis, unit step response probably. Unit step response is nothing but the response of the system for a unit step input. That's it. If your R of s is 1 by s, how your system will respond. And if you get an equation like this, now you can substitute different values of t. And if you want to know what is the plot, you can substitute different values of t, and you can plot it for between C of t and t. Okay, C of t and t. Probably if you substitute 0, you substitute 0, then what you will have, this becomes sine 0. Sine 0 is 0. Second term will become 0. The third term. The second term is cos 0 is 1. E power 0 is 1. So cos 0 is 1 and e power 0 is 1. 1 into 1 is going to be 1. 1 minus 1 is 0. So it starts from 1. It starts from 1. Okay, 0. And if you substitute t equal to infinity, what happens? The second term and the third term becomes e power minus infinity, so they become 0, and it will have some oscillations probably, and it will settle down. Okay, so it's probably going to be settling down around 1 at infinity. when t tends to infinity, it will try to settle down. It is not going to be exactly the same as what I have drawn. It may be different. I am expecting that it is going to be an underdamped system if my zeta and omega is going to be okay, zeta is going to be less than 1 and between 0 and 1. Okay, that's it. So you have to check whether my zeta and omega is going to be less than 1 and zeta is going to be less than 1. You can comment about it. Even if you take that, we will verify that. Okay, so your closed loop transfer function is 10 divided by s squared plus 4s plus 10. Okay, so omega n is equal to omega n squared is equal to 10, which will give you omega n is equal to square root of 10, and 2 zeta omega n is equal to 4, and so zeta is equal to 4 divided by 2 into square root of 10. Let me check that. If you have a calculator with you now, kindly tell me whether it is underdamped or critically damped or overdamped. I will take my calculator and parallelly I will do also. So what I will have, 4 divided by 2 into square root of 10. Is that I am getting it like 0.632. So kindly check that also. 2 divided by 4 divided by 2 into square root of 10. Okay, it's coming at like 0.632. Anybody got the answer? Hello, the class, please. So your zeta is lying between 0 to, yeah. Thank you, Sibi. So you are getting zeta value between 0 and 1, which is 0.632. So it is an underdamped system. Okay, so underdamped system will start from 0. It will try to oscillate and it will settle down. So this is your C of t and this is your t, and it settles down at 1 unit step input for R of s, right? So this is so these are the informations which can be shared using this problem. Okay, so this is your second problem. Please go through that. Go through the problem first, then we will discuss about what is being provided. It is the reversal of the first problem. If you understand the first problem, then you are going by behind it. Behind it, what is that? Here, the response is provided. You can see that the response is provided. Yes or no? CFT is provided. Okay, they are asking for obtain an expression uh, of the closed loop transfer function. Okay, they have given you C of t. They are asking it for what is C of s by R of s, and they have given us R of s is also unit step input. Unit step input. So they are asking it for C of s by R of s is equal to what? Okay, C of s by R of s is equal to what? And they are asking to find what is undamped natural frequency, that is your omega n, and damping ratio. Damping ratio is zeta. Damping ratio is zeta. So you are supposed to find what is C of s by R of s, and if you have a transfer function with a nice numerator and denominator polynomial, then you can find your zeta and omega n, which will be available from your uh, denominator polynomial. That is your characteristic equation, general form, s square plus 2 zeta omega ns plus omega n square. So it's the reversal. It's a reverse of the first problem. First problem, what they have provided? They have provided C of s by R of s in a type of a block diagram. We found C of s by R of s. From that, we have tried to find what is C of t. Okay. Now, what they have given? They have given C of t. They are asking for C of s by R of s and the parameters omega n and zeta from that. Got the idea? Yes or no in your chat window, please. போன ப்ராப்ளத்தில் நமக்கு சிஎஃப்எஸ் பை ஆர்எஃப்எஸ் இருந்தது, பிளாக் டயக்ராம்ல இருந்து கிடைச்சு அதை வந்து நம்ம மாடிஃபை பண்ணி நம்ம என்ன பண்ணியிருக்கிறோம், ஒர்க் பண்ணி சி ஆஃப் டி கண்டுபிடிச்சோம். இந்த ப்ராப்ளத்தில் சி ஆஃப் டி கொடுத்துட்டு நமக்கு ரிவர்ஸில் போகிறாங்க, சி ஆஃப் எஸ் பை ஆர் ஆஃப் எஸ் கேட்குறாங்க. அதுக்கப்புறம் என்ன கேட்குறாங்க, அதில் இருக்கக்கூடிய ஒமேகா எண்ணையும் ஜீட்டாவும் கண்டுபிடிச்சு சொல்லுங்க அப்படின்னு கேட்குறாங்க. ஸோ இஸ் தட் ஓகே? ஷால் வி ப்ரொசீட் வித் த ப்ராப்ளம்? Hello? Right. So I have taken my response. So what is my first step? To get C of S by R of S, I have to go for Laplace transform. So taking Laplace transform, what I will get? C of S is equal to 1 will be provide me 1 by S plus 0.2 into what is e power minus, is that 6 or 60t? It is not 0.06, it is 60. Okay, I think I have made a mistake in the problem also. Okay, it is a 60. Okay, not 0.6, 60t. Okay, so this is the change. You kindly make it out. Okay, in the problem also. So 0.2 divided by s plus 60. Why? Because Laplace transformation of e power minus at can be written as 1 by s plus a. Okay, so that's it. Minus 1.2 divided by s plus 10. Now if I take I have taken the Laplace inverse. Now I have to group it and try to get it as a polynomial in the numerator as well as in the denominator. So I have a C of s which is equal to, if I take an LCM, what I will get? I will get s into s plus 10 into s plus 60, which is going to be s plus 10 into s plus 60 plus 0.2 into s into s plus 10 minus 1.2 into s plus 60 into s. So if you see the numerator, you have s squared plus 600s plus 70s, not 600s. S squared plus 70s plus 600 plus 0.2 s squared plus 2 minus 1.2 s squared. I think we'll have 2s, okay, 2s. And minus, what is 60 into 1.2? 60 into 1.2 will give me 72. Okay, so minus 72 s divided by s into, okay, s squared plus 70s plus 600. Now you can see that you can cancel out all these things. This s squared plus 0.2s will give you 1.2. This is minus 1.2. Okay, this is 2 minus 72 will give you minus 70 plus 70 is there. So this is also getting cancelled. So my C of S is equal to what? 600 divided by s into s squared plus 70s plus 600. Okay, or I can write it like 1 by s into 600 divided by s squared plus 7s plus 70s plus 600. Okay, this 1 by s, what I can write? How can I write this 1 by s? What is 1 by s here? Your output C of s is provided. If I want C of s by R of s, 1 by s is what? Yes, good, CV. So I can write this as C of s is equal to R of s, because in my problem, what is provided? The R of s. The input is unit step input. Okay, this is R of s is equal to 1 by s. So I put R of s instead of this. So you will get 600 divided by s squared plus 70s plus 6. So I can write this as 7 C of s by R of s is equal to, I bring this R of s here. I will get it like 600 divided by s squared plus 70s plus 600. So this is what is being asked as the first part of the problem. The expression for a closed loop transfer function. Okay, then we know what is the standard transfer function, second order transfer function, omega n. Is that right? Omega n squared divided by s squared plus 2 zeta omega ns plus omega n squared. If you compare these two, omega n squared is equal to 600, which implies what is omega n? Square root of 600. What is square root of 600? Square root of 600, 24.49. Is that right? Radians per second. Now you have 2 zeta omega n is equal to 70, and zeta is equal to 70 divided by 2 into omega n. So 70 divided by 2 into square root of 600 into 2 into 70. How much you get? 1.429, or I can write it like 1.43. Can you comment about what type of damping is here? What type of damping is here? Can anybody unmute your mic and answer? That makes the class lively, and I will be happy if I get an answer like that, not through a chat window. Since zeta is greater than 1, what type of damping it is? Unmute and answer, please. என்னடா உன்னை பாட சொன்னா ரைட்டு, எல்லாம் சாட் விண்டோல தான் போடுற ஓவர் டேம்ப். எஸ் கரெக்ட் சிபி. அதான் அன்மியூட் பண்ணி சொன்னிட்டா முடிஞ்சு போச்சு. டைப் பண்றதுக்கு என்ன, இட்ஸ் ஓவர் டேம்ப். ஓவர் டேம்ப் சிஸ்டம். Okay, so the question is giving me that only. What it is asking, obtain an expression of a closed loop transfer function, determine the undamped natural frequency and damping ratio. So that is also been solved. Okay, now we go to the third problem, or I will ask you if you want me to explain it again in any of the point which is left in this problem, which we have discussed already. Any point I want to stress more, any point you have a doubt, you kindly ask me now. I can explain it. That's not an issue at all. Any doubts, please? Hello? Any doubts? Okay, only Suji is responding. I don't know why the others. Okay, Pragdishwari, Shivakumar, fine. If you are unable to, yeah, you are Jayvel. Okay, fine. So if you are able to get that information, that's fine. Let us move to the next problem. Okay, so this requires yesterday's class video being uh, gone through the video of yesterday's video. Then you might have known what this problem suggests. Anyway, we will try to solve that. We'll try to solve that. Okay, so what is the problem statement? Calculate the following parameters. The following parameters are delay time, rise time, percentage peak overshoot, and the settling time for a system whose natural frequency of oscillation is 10 radians and damping ratio is, so this is your omega n and this is your zeta. So giving your omega n and zeta, you are supposed to find what is delay time, rise time, maximum peak overshoot and settling time. Okay, just give me 1 minute, take a cup of water, then we will discuss further. Okay, thank you very much. We are back. We are back actually. Right. So this is the data. Omega n and zeta is provided, and you are supposed to find what is delay time, rise time, peak overshoot percentage, and settling time. Since it is provided as 0.707, it is an underdamped system, directly stating out the underdamped system. Let me carry that to the next page. What are they? Omega n is provided as 10 and the zeta is 0.707. They are asking for delay time. Okay, delay time is equal to formula 1 plus 0.7 zeta divided by omega n. So substituting that zeta value and omega n, you might get the value as 0.15 seconds. It's nothing but the formula TD, delay time or TD, 1 plus 0.7 zeta by omega n. This is being derived. Okay. Number 2, rise time. Rise time TR. And I have mentioned you that while you calculate rise time, your calculator should be in radian node. Very important. People get wrong answers if it is not allowed. Pi minus theta divided by omega d. I can write it like pi minus theta divided by omega n into square root of 1 minus theta square. If you substitute instead of theta, what is theta? Theta we have already derived tan inverse of square root of 1 minus theta squared divided by theta. This we have derived the second order transfer function in your second lecture. If you can go through that video, probably you will be getting it like tan inverse of square root of 1 minus zeta squared by zeta. If you substitute that, you will get a theta value. Theta value is going to be 0.7855. If you substitute that, omega n and zeta is also known to you, you will get a value here as 0.333 seconds. Okay, 0.333 seconds. Then you are supposed to find what is maximum peak overshoot. Percentage of maximum peak overshoot. The formula is e power minus zeta pi divided by square root of 1 minus zeta squared. This is exponential into 100. Zeta is known to you. If you substitute that, you will get it like 4.32%. Okay. Then the last one is settling time. Yes, settling time. And this is for settling time for 2% tolerance band. We have two formulas here for 2% and the other one is for 5%. We have two formulas. First formula is 4t, which is equal to 4 by zeta omega n. You will get it like 0.057 seconds. And the second one is 3t, which is 3 divided by zeta omega n, which is equal to 0.42 seconds. That's it. You should know the formula. Just apply that in the formula, and you'll be getting the answers. And very carefully, you can use this radian mode while you are calculating rise time, because you are involved with the theta there. Okay, so you are supposed to do based on rise time using radian mode, right? So this is the methodology. All these formulas are discussed in yesterday's class probably. Okay, you can go through that lecture again. If you go through that video, you will get the point. Okay. The same way, instead of providing you with undamped natural frequency, they have given you a transfer function. You are supposed to find the k value, and then you have to find your omega n using that zeta provided and the omega n. What you are going to find, you are supposed to find all these things: settling time, peak overshoot for a unit step input. And since it is zeta is equal to 0.5, this is going to be what? Under damped. All the formulas what I have used the previous problem is coming under underdamped system only. We will see this problem number 4 and problem number 5 in the next class. Meanwhile, if you have a doubt, you can discuss with me regarding the third problem, second problem, and first problem. Anybody have a doubt? Hello? Are you there in the class? No doubt, sir. No, sir. Okay then. Okay then, fine. So, if that is the case, we can leave. Thank you very much for joining today. And people, do you know the timetable? Already, I think it has been posted in your WhatsApp group. So kindly make a note of 2 days. We have fifth hour class yesterday and Friday and Monday. So other subjects may have 4 hours, but my subject will have 6 hours, because 75 hours period should be taken as per the suggestion of university norms. Okay, so I have 6 hours per week. So please join all the classes without any deviation. Thank you very much for joining today. See you. Bye.